The OGC is a collaborative international forum committed to fostering open standards for the global geospatial community. We believe in a world where everyone benefits from the use of freely available geospatial information and supporting technologies. Sponsors and participants from government, commercial organizations, NGOs, academic and research organizations all come together, driving innovation during the course of each testbed. Developments occur in several domains, including environment, defense, health, agriculture, meteorology, and sustainable development. With over 130 deliverables and 7 scenarios, this was our most ambitious and successful testbed ever. In our scenario, a severe earthquake in San Francisco damages the city's infrastructure. Many roadways and bridges are impassable. Power and cellular communication has been lost in a number of areas. An emergency command center is established to aid in evacuation, response, and recovery. To accomplish this, sharing critical data about roads, buildings, and the power distribution network is required. The existing San Francisco SDI plays a critical role in the efficient discovery and access of data and classified information. An analyst searches the catalog and displays the data, then selects the critical instances they would like to share with other command centers. The data is stored in an OWS context file that provides links to all of the services, which will enable emergency responders to share a common operational picture. The client is looking at data about water, elevation, and national land cover. The web map tiling approach facilitates an efficient request for millions of images on the web. The analyst zooms in, easily accessing vast amounts of data without any memory or performance concerns. The analyst can also access a service that streams LiDAR data, allowing visualizations and interactions with unprecedented speed. The command center can also request notifications of aftershock events via OGC PubSub and Event Web services. The client application receives notifications informing the user that 10 events are available. People working in the emergency command center have different credentials, and some information is classified. In order to retrieve certain data sets, the user must provide the right security certificate. An analyst with the right credentials accesses classified construction site data via SOAP services, so they can coordinate an ideal location for search and rescue helicopters to land. Because landlines and cellular networks are down, the team at the command center must find another way to share data. Humvees outfitted with mobile servers arrive at the command center and synchronize with the command center server, gaining vital information, for example, a map of every temporary shelter that is available. In the field, if the rescue and operations crew spots a possible shelter that is not on the map, the crew can update the data on the vehicle mobile server and sync back to the command center on its next visit. Response centers can also exchange or synchronize information in a similar method using OGC web feature services. In this scenario, we utilize 2 different cloud environments. This maximizes the request and response time between servers and clients.
There were certainly implementations today that showed how we would use a distributed environment to do what we do, to do it more efficiently, both faster and higher quality.
The command center needs to calculate the best off-road route to support its operations. They create a geopackage file that contains tiled satellite image and elevation data, road closures, wildfire boundaries, and hydrography. They are able to calculate an off-road route that avoids obstacles stored as vector data such as bodies of water. Mobile National Guard units investigate off-road routes to bypass a closed road and to clear a wildfire boundary by using geopackage data provided by the command center.
The advances in geopackage have allowed the disconnected user out in the field to receive larger amounts of data than we've ever seen before.
Because the command center is accessing data from a number of different organizations, they inspect the quality and accuracy of the data before they perform any data merging or conflation. Any new data is compared to authoritative data by selecting a random sample of points and a percentage threshold. In this case, 20 points were selected and the percentage of failure was set to be less than 20%. The analyst is also interested in merging complementary data to the authoritative data Using resources discovered via catalogs, the EOC client retrieves road network datasets in the San Francisco Bay Area to support the National Guard and other civilian responders that are being deployed into the area. However, there are differences between the features in these datasets. The analyst performs a library conflation process using a tool called Hootenanny, which is executed as a REST OGC web processing service.
The ability to conflate our data, take data from multiple sources, resolve that geospatially, and then provide that back to the agency.
The earthquake has triggered a number of fires. Another analyst at the command center runs a smoke dispersion model, then accesses a special web coverage service to view the results. Because this service implements an Earth observation profile, the analyst can view the data in 3D space and in real time. Interoperation between disparate, unaligned data is a major problem that OGC solves with web coverage services and the discrete global grid system standards.
The thing that surprised me most was the ability to take a client, connect it to an OpenDAP service, and retrieve that data and display it in a three-dimensional view where you actually saw the smoke coming out from San Francisco.
A wildfire has been reported along an unexpected evacuation route. An analyst can estimate the fire extend boundary via a web service, then encode it in GeoPackage, enabling first responders to access the data on their mobile devices. To transmit the files more efficiently, they run a line generalization computation via a web coverage service, reducing their size by 85%.
In the testbed, you can align different experiences with lots of smart people and drive innovation at remarkable speeds.
With more than 500 member organizations worldwide, the Open Geospatial Consortium is the leading organization for developing and maintaining international geospatial and location standards. Through the OGC, technology users are able to maximize the value of past and future investments in geoprocessing systems and data. By getting to know, evaluate, and work with interoperable technologies in real-life testbeds, our members develop architectures, enabling systems that allow them to share and reuse data, positioning their organizations to choose the best tool for the job, optimize workflows, and reduce risk.